And question 2. Well, we want to draw the differentiated or the gradient function. Now I've drawn a line there. The gradient at that turning point is 0. Here's another line. Between those 2 points the gradient's -3, and I've drawn a third line, the gradient is 3. So you've down right below where I've got -3 in the center of that blue line, the gradient graph has to be -3. It has to be 0 right below that point, and it has to be 3 right below that point. Join them together, it should cross at y equals 2. Here's your gradient function. When you think about it, when you differentiated an x squared, you'd get a 2x graph, wouldn't you? Multiply by the power, reduce the power by 1. That's for understanding. For the next one, we've got a monthly profit. We're asked for the maximum monthly profit. That should trigger in your mind, differentiate. So we're going to differentiate by multiplying by the power, reducing the power by 1. Tidy that up. Remember, an x term goes to a single number, and the -1000, it's got no x term, it disappears. Because we want the maximum, we want to make it equal 0. That's at the top, and so you solve for that. You find that x equals 300 when you divide by 0.8. Now once you've got that, you put that into the profit equation and work it out on your calculator, and you should get $35,000 profit. That's for achieved level. For the next one, we want the equation of the tangent. You should know that a tangent is a straight line, and the first thing we do is find the gradient. That would mean you would differentiate gx, multiply by the power, reduce the power by 1. Now you've got x equals 2 there, so put 2 into that equation, and you find the gradient at point 2 is 7. Now that you've got the gradient, you can find the equation of the tangent, and put the whole 0.26 into there. Y is 6, x is 2, and you get the answer of -8. Write the full equation out, and that is merit level. For this next one here, you want a square base pyramid, or cuboid rather. So draw out your cuboid. It's got a square base, and the height is twice the length. Now we want to find the rate at which the volume is changing, so we need a volume equation. That's base times length times height. It says a rate of change. That means we're going to have to differentiate that. Multiply by the power, reduce the power by 1. This time we don't make it equal 0 because we're told that the base length is 2. So you put 2 into the differentiated equation to give you 24. That's centimetres cubed per centimetre. That's the rate of change. That's merit level. For part E, we've got this horrible looking equation. We're asked to find the rate of change of R when it's a maximum. So if we need a rate of change, we better differentiate it. But before we differentiate, we need to expand out the, what's that 3 doing there? We need to expand out the brackets there. So you multiply the brackets, then you differentiate. Oh, going too fast here. Okay, then we need to double differentiate it because you're asked where the rate of change of R is a maximum. We've found R, that's in the purple, bluish purple. We want the rate of change, so that's when you do the double differentiate, and we find that K equals 2D. That is a maximum. D equals K over 2. That's for excellence. For what interval is this quadratic function increasing? You might think, what's all that about? Well, there's a quadratic function. It's increasing after the turning point, so we want to find where the turning point is. So differentiate it and make it equal 0, and we know that the turning point is where x equals -b over 2a. Now the rate of change for this positive one, if a is greater than 0, it's increasing when x is bigger than -b over 2a. That's not going to give you excellence unless you do the other, but you could have an upside down parabola, which I'm going to sketch in a moment, and it's increasing up to the turning point. So if a is negative, then the function is increasing when x is less than -b over 2a. That's for excellence. We've done that question.